your 64-bit app, it's just on, third party or not. And so this is something that, like I said, this is a differentiation that we can make to go improve the overall security. Another mitigation we introduced was function pointer encoding. So if you're able to, if you find a security vulnerability and you're trying to exploit it, one way you get your code to run is you go bash a function pointer to point back to your code. And so one technique that we introduced was to go encode, an ability to go encode function pointers with cookie values. So when you set up your function pointer, you XOR it with a cookie that is either per process or per boot. And now when the attacker, when he goes and smashes your function pointer, he's got to somehow choose a value that is going to point back to his code after a successful XOR decoding of the cookie. And so it really makes his chances of predicting that much, much more difficult because it's different either per process or per app or per boot. When I looked just at beta 2, there was over 300 instances of usage of this function pointer encoding, so it's really being applied fairly broadly in Vista. Some of the routines you may be familiar with are listed below. So NX is something that we introduced capability for in XPSP2. The default mode is that applications and services opt into it. So all the services in Windows Vista are opted into supporting NX. One of the nice things about the fact that Vista requires beefier hardware is all the new hardware that will come out to support it is going to basically have native NX support in it. So it's a nice change from the past. And customers can take Windows and put it, basically opt everything in despite whether the app wants it or not. When NX first came out, the SWI team, we really didn't jump up and down about NX. It's a great step forward, absolutely, but we know there's attacks to circumvent it. There's these return to libc attacks and whatnot that can circumvent it. And so by itself, it's not a complete mitigation. And actually, all these mitigations by themselves are not complete in and of themselves. There was a nice paper written by Skywing and Matt Miller about bypassing data execute protection. And one of the things they noted in the paper was that one helpful complementary technique to data execute protection was address space layout randomization, to move things around in memory to defeat these return to libc attacks. And so in Windows Vista, we introduced, implemented ASLR. Like I said, it's a powerful complement to NX. You really need both of them to actually get anywhere. The final design is still being tweaked, but the way it is going to work is a DLL or an XE will opt into ASLR, and so certainly the operating system is going to be opted in, and people will be able to get a QFE from the compiler team that'll have a new flag so that they can take their application and opt them into ASLR. It's essentially just sets a bit in the PE header. The main design challenge that we had to face with ASLR is there's a trade-off between how much randomness you want to have with the addresses of your DLLs in memory and how much contiguous virtual address space that you want to have available to an app. And so the more you fragment the address space and increase the randomness, the smaller contiguous Alex you can do. And the net might be you run SQL Server, and you know what? It can't run like it used to because it can't get that same huge virtual ALEC that it used to. And so this could cause application compatibility. So we chose a design to try to maximize the entropy here, but also try to maximize the amount of contiguous virtual address space. The net on it was there actually was not any big hiccups by introducing this into the OS, which was a bit of a surprise for us. The performance guys looked at it and they said, you know what, performance isn't going to be a problem. In some cases, you get small wins because of the particular design we took where part of the virtual address space is compressed. And there's some minor losses in corner cases, but by and large, perf is not going to be a problem here. We took 600 of the top popular third-party applications and ran them through an application compatibility test suite with Vista. None of them failed because of ASLR. So we think this is actually some really great stuff here. And so in closing, I'd like to compare, I thought this was an instructive way to walk through all the different efforts and all the different improvements that we've been making in the operating system through SDL. If you look at the Zotob worm, which was, as I mentioned, a vulnerability, a remotely exploitable vulnerability in an RPC interface. And you think about that, if you haven't heard of Zotob, that's good because Zotob was the next blaster. It really was. Same kind of buffer overrun and the same kind of service. And the reason it didn't turn into as big a deal as Blaster is because while in Windows 2000 it was remote and unauthenticated, which basically means game over for you. In XPSP1, that interface was made authenticated. And so while you could still have a worm that circulated within a corporation, you couldn't go and bridge corporations because you couldn't authenticate outside of the space where you can authenticate. In Server 2003, that interface was made admin only, and so essentially there was no remote vector. That improvement, that security callback, was backported to XPSP2, and even if we had missed an XPSP2, the firewall was on by default and blocked it. Now imagine that vulnerability was still present in Windows Vista. So in Windows Vista, we've taken and improved prefix and prefix code scanners to recognize a broader, much broader array of common coding patterns, and use SAL to help it find those defects. Even if that failed, we did RPC fuzzing and penetration testing of RPC interfaces to go after and find these defects. And even if that process didn't find that particular defect, we have the code is protected by an improved version of /GS and SafeSEH. Even if that failed, services are opted into NX by default and are using ASLR. And even if that failed, it's still blocked by the firewall that's on by default. There's a bunch of other talks coming up. Go see Abelade's talk on the stack if you're really interested in what we did there. Noel is talking about Wi-Fi and wireless. Adrian's got a talk on the heap that's really great, and Rob's going to be talking about IE7. And with that, I'm going to close it. I thank you for your time and your attention, and I'll be at the Microsoft booth to answer any questions that you have.